Okay, so today the topic is going to be 7.1 exponential functions. All right, so what we did yesterday with the M&Ms was that you created an exponential function. The parent function is y equals b raised to the x, where b is going to be a number that's called the base. That's why I think that's probably why they use b is for base. And if that base is greater than 1, then the function is exponential growth. And it's going to be increasing everywhere. So it will be increasing. All right. If that base is less than 1, so like a fraction between 0 and 1 or a decimal, then it's going to be exponential decay. And it's going to be decreasing. So those M&Ms, that function, do you guys think that was growth or decay? It was decay. So the number of M&Ms kept getting smaller and smaller and smaller. That's decay. Right? All of these exponential functions have an asymptote. They technically have a horizontal asymptote. And I don't think that's a word that you guys have learned before, but I could be wrong. But an asymptote is going, for this case, is going to be a horizontal line. The graph gets closer to on the far left and or just kidding, far left or the far right. All right. So yesterday when we were doing the M&Ms, what do you guys think the horizontal asymptote was? Like how many M&Ms was it getting closer and closer and closer to? Zero. And some of you got to 0. Some of you probably didn't. So that the horizontal asymptote yesterday was 0. All right, so we're going to do a few graphs. We're not going to do all of these characteristics over here, so I'll tell you which ones to mark out in a second. But let's look at this equation. Do you guys think this one's going to be growth or decay? We look at the base, which is 2. So do you guys think this one would be growth or decay? Growth. So if the base is bigger than 1, it's going to be growth. All right, so I'm going to go to the calculator. Right. And I'm going to type it in. So go to y equals in your calculator. Right, and then it's going to be 2. And then the button for an exponent you probably already know, but I can't reach up there, but it's the button above division. It's like a little rooftop. So 2 raised to x. Okay. And so if we hit graph, you can kind of see what that graph looks like. And that is growth. Starts off kind of flat and then it increases quickly. All right, but I'm going to go to the table and get some points. So do you guys remember how to go to the table? Good. Second graph takes you to a table. I'm just going to jot that down. All right, and then I'm going to plot those points. So 0.125 is super, super close to 0, so -3, and then just right above the x-axis. 0.25 is also pretty close to 0. All right, so this one, we're going to go through these points, and it's going to be flat on one side and then curve up through the points. All right, so that's the graph, exponential growth. Now make sure that on this left side that you went flat, that you didn't like start going down, like, or go underneath the axis. All right, so we are going to do the domain, the range, and the asymptote. The stuff in the middle, we're not going to worry about. All right, so if you have an arrow pointing to the left and you have an arrow pointing to the right, what do you guys think that means about your domain? All real numbers. So we can do the fancy R for all real numbers. All right, and then this graph is just going to get closer and closer to 0, but not quite get there. So the range is going to be that y is greater than 0. Right, and then the asymptote is going to be the line where it goes flat. So where does this one go flat? 0, 0. Good. So it's just going to be y equals 0. These two should always be the same number. All right, so what questions do you guys have so far? We're going to change number 2, so if you're working ahead, hold off because I don't like it. It's too much like number 1. I want it to be different. All good? Okay, let's look at number 2. Let's change it though. So let's just make it y equals, and then in parentheses, 3/4 raised to the x, and then out to the side, we're going to put -3. All right, so let's type that in. That was almost bad. I don't need to break it. All right, so y equals, we're going to clear it out. Now, instead of doing 3/4 like a fraction, it's going to be better for us if we just do 3 divided by 4. I promise it's going to be better. Because your table will be a bunch of fractions if you do the alpha y equals. All right, so I'm going to go to my table. Oh, sorry. You guys need to see that a little bit longer. It's okay. I'm going to go to my table. I'm going to jot that down. I'm just going to round to 2 decimal places on these. Oh, I didn't ask you all. Do you guys think this one's going to be growth or decay? This one's going to be decay. 3/4 is the base. 3/4 is smaller than 1, so it's going to be to k. All right, I think I might have messed up on that first point. Hold on. Three for my what? Okay. So where does it look like this one is leveling off at? What do y'all think? Yeah, it's going to be -3. So it starts going flat at -3. So we can go ahead and say that if you want to. Y equals -3 for your asymptote. Right, and so that's going to, if there's something that's added or subtracted at the end of the problem, that's always going to be your horizontal asymptote. All right, so domain is still going to be all real numbers on all of these. And then the range is going to be y is greater than -3. So this number bumps up to there. Bless you. All right, any questions? All right, so on the back, there is a graph on the back, but we're not going to do it. We're just going to talk about transformations again. We've talked about this in every single unit. We've talked about it with quadratics and then cubics, all the different types so far. So it's the same rules that we've been talking about. So if we have this h right here, there's two places we can add and subtract. We can add and subtract inside and outside. Would you guys say that h is inside or outside? Inside. H is the inside. So subtracting and adding on the inside is a horizontal shift. All right, so the inside is the one that's the opposite of what you would think. So adding on the inside actually shifts it to the left, and subtracting shifts it to the right. All right, and then this K is on the outside, and adding and subtracting on the outside is a vertical shift. Where adding is going to shift up, and subtracting is going to shift down. Okay. And then A tells you two things. So it tells you if there's a reflection. So if this number in the front is a negative, then there is a reflection across the x-axis. So you just check for a negative out there for reflection. And then it also can stretch or compress. So if that number is greater than 1, it's going to be a vertical stretch. And if that number is between 0 and 1, smaller number, is going to be a compression. All right. So we're going to do 4 of these. The first thing we're going to do for each of these is write what the parent function is. So the parent function is going to be different for each of them. So it's y equals, and then it's just whatever the base is in the problem, which in this case is 3, raised to the x. So you're taking away any multiplication, addition, or subtraction. So what that leaves, if you compare...
Miss Skipper, we need Jonathan Escobar to come to the office, please.
Okay, he's on his way.
Thank you.
You're welcome. So we compare this one to this one. The only difference is this plus 5. So what is that plus 5 going to do? It's going to shift it. What direction? Up. So adding outside shifts it up. So it's going to be up 5. All right. So let's look at the next one. So we'll start off finding the parent. So it's y equals, and then just the base. The base in this case is 1/4 raised to the x. All right, so if I'm comparing the original to the parent, there's 2 things that are different. So that 2 that's in the front is positive, so it's not a reflection, but is it going to be a stretch or a shrink? A stretch or a compression, I should say. The 2. Stretch. So we'll have a vertical stretch. All right, what do y'all think about the -1? So it's subtracting inside, which is going to shift to the right. So right 1. All right, let's look at number 3. Sure. You're welcome. All right, so we're doing the parent. It's just the base, which is 4/3, raised to the x. This one has 3 things. All right, so that negative in the front, the negative in the front is going to be your reflection on the x-axis. What about that +2, adding on the inside? Left, right, up, down. What do you think? Left. Oh, we're up, sorry. So left 2, because it was up there with the x, is going to go left or right. And then the 7, what do y'all think? Up 7. Very good. All right, you guys try number 4 on your own, please. Okay, so because that 1/2 is smaller than 1, it's between 0 and 1, that's going to be a vertical compression. The -4 up there at the exponent is going to go right 4. And then the -2 at the end is going to be down